So in today's video, we're going to be discussing how to write an electron configuration for a particular atom or element. And this electron configuration is just going to show where the electrons are located in the energy levels and sublevels when that atom is in its ground state, when it's at its lowest energy possible. Now, how these electrons are located around this nucleus and in this electron configuration depends on three rules. Depends on, first of all, the Aufbau principle. The Aufbau principle says that electrons in an atom enter orbitals of lower energy first. So it's going to fill up closest to the nucleus and then go out from there, go from the first energy level out to the second energy level to the third energy level, etc. Now, based on our discussion that we had in the previous notes, it would make it seem that the electrons would enter the orbitals in this order: 1s, because that's all there is in that first energy level, then 2s and 2p in the second energy level, 3s, 3p, and 3d in the third energy level, 4s, 4b, 4p, 4d, and 4f in the fourth energy level, etc. However, this does not happen, and it doesn't happen because of something that occurs called overlapping. And overlapping is when sublevels from higher energy levels end up being slightly lower in energy than the electrons from lower energy levels, which seems totally counterintuitive, but they just overlap a little bit, and so the sublevels start occurring out of order as far as energy is concerned. And you can use the periodic table to determine the actual order of the sublevels. So on the next page, you should have a periodic table that's not colored, but it looks like this. And what I'd like you to do is to pause it here, pause this video, and I need for you to color your periodic table in these particular colors. It doesn't have to be these colors, but it has to be in these sections. Notice a couple of things. Notice, first of all, that where I've got the two yellow rows over on the left, notice that helium over on the far right is the same color. That's important. So it doesn't matter. I would say it'd probably be easiest to do it in matte pencil, but you're welcome to do it in marker. I would just be careful. You don't want to cover up the element symbols because we're going to need those for what we're going to do with this periodic table later. Don't forget to also write in these sublevel numbers, the 1s through 7s over on the left. Notice that there's a 1s over here with helium, so make sure you label that. The 2p through 7p over here on top of around group 3a where that section starts. Then 3d through 6d over where the transition metals start. And finally 4f and 5f are down here on these bottom two rows. So make sure that you get those labeled. Okay, so hopefully you did that. Now that you've got this periodic table colored, let's look at what the order of the sublevels would be based on this periodic table. Now, what we're going to do is read from left to right. So I'm going to get rid of these arrows here. And I want you to read from left to right across the periodic table and then keep going down the periodic table. So what we end up with first is 1s. So that's our first sublevel. And it goes across and picks up helium. The next that we have is 2s. So that's our next sublevel in order. Now going across the periodic table, we then pick up 2p. And so far so good with what we would think the order would be. Back over to the left, 3s, then 3p. Back over to the left, 4s, and this is where our first case of overlapping occurs. Notice that the next one we come to is 3d. So that's what we're going to write down next is 3d. After the 3d comes the 4p. Then left to right again, 5s, 4d, then 5p, six s, and now this is where you're going to get messed up if you're not careful. What I want you to write next, I want you to pretend that this break occurred right here before it drops down to these bottom two rows. So what's going to happen is after we get done with 6s, we're going to drop down, and notice it goes 55, 56, and then yes, we have a 57 in there. It's kind of a weird thing that happens, but like I said, I want you to make the break early and go down and pick up 4f. So we're going to pick up 4f next. Get that in the right color. 4f next, and after 4f, then we're going to go back and pick up 5d. So this is the order I want to see it in. After 5d comes 6p. Then we'll go back to the left and pick up 7s. Be careful if people are going to miss this. This is where they miss it. After 7s, you're going to go down and pick up 5f. And then pop back up and pick up 6d. So you've got to remember to do that. And finally, the last one that we're going to deal with is 7p. And yes, we don't have all of the elements extending out here, but there are others. So we are going to use that 7p. So that's the order of the sublevels that we want to have. Now you're going to get to use this list, of course, as you're doing your homework assignments and things, but you won't get to use the list on the test. So you really want to be practicing using the periodic table itself in order to find the sublevel list, because you're going to have to do that on the test. So going back here then, the Pauli exclusion principle says that no two electrons in the same atom can have the same four quantum numbers. So this is really talking about how we would orient them in their orbitals if we were doing a orbital notation or something where we're specifically showing what was happening to the electrons in their orbitals. And Hund's rule would also apply to that, talking about how electrons can't exist in an orbital unless they have opposite spins. Now we talked about the orbitals that were in these sublevels in the last set of notes. And we're going to group those together when we do the electron configuration. So let's look first of all at nitrogen. The first thing you want to do is to find the element on the periodic table on your colored chart. And nitrogen is right here. And notice that nitrogen is in the 2p block. So here's that 2p, and it's in what we call the 2p block. So we're going to write down everything up to and including 2p to write that electron configuration. And so if you look up here, that's going to include 1s, 2s, and 2p. So let's go back and write those down on our example. So we've got 1s, 2s, and 2p. The next thing that we need to do is to, according to the Aufbau principle, fill up every energy level and every sublevel up until the last one. They're going to fill up from the bottom. Now remember our discussion last time. We said that an S sublevel could hold 2 electrons. A P sublevel can hold 6 electrons. A D sublevel can hold 10 electrons, and an F sublevel can hold 14 electrons. So keep that in mind as we write this. So both of our S sublevels, it doesn't matter whether it's 1s or 52s, it still holds 2 electrons. So we're going to show that by putting superscripts here. So this tells us that we have 2 electrons in the 1s, 2 electrons in the 2s. Now let's go back and figure out then. Yes, the P sublevel could hold 6, but let's look how many nitrogen has. It's easy to tell how many electrons an element has in its last sublevel by simply counting over from when that sublevel started. In other words, boron here would have 1 electron in the 2p sublevel. Carbon would have 2 electrons in the 2p sublevel. Nitrogen would have 3. We would have to be neon before we'd have all 6 electrons in that 2p sublevel. So we're going to show that back here on our diagram on our electron configuration with a 3. And that's the electron configuration for nitrogen. Okay, let's do iron real quick. Let's see where iron is located. Iron is located right here on the periodic table. So it's located in the 3D block, in that 3D sublevel. That means that iron's outermost electrons are in the 3D sublevel. So we're going to write down everything on iron for iron up to and including the 3D sublevel. So we're going to go all the way up to 3D. So let's write all of those down on our problem back here. So we have 1s, 2s, 2p, 3s, 3p, 4s, and 3d. And now remember, up until the last sublevel, we're going to have all of them full of electrons. All of the S's are going to have 2. All of the P's are going to have 6. Look at the red values up here, reminding ourselves how many they can hold when they're full. Finally, that D could hold 10, but let's see how many iron has in its outside energy level. If you notice iron, we start at where 3D sublevels start. So iron has 1, 2, 3, 4, 5, 6 electrons in that 3D sublevel. So let's show that on its configuration. And that completes the electron configuration for iron. So we're going to do one more, platinum. Platinum's our longest one, our biggest one that we're going to do. And we need to locate, first of all, where platinum exists on the periodic table. And it's down here in the 5D sublevel. So we need to write everything up here up to and including 5D. So let's do that really quickly. So we've got 1s, 2s, 2p, and you can follow along on your periodic table if you want to. 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, and I've run out of room, so I'm going to start back down here. And after 5p comes 6s. Now watch it. This is where people mess up. 6s, 4f, and then 5d. So make sure that you include that 4f between 6s and 5d. And now we're going to fill up everything up to the last sublevel because they're all going to be full. So all of the S's are going to have 2. All of the P's are going to have 6. All of the D's, except of course the last one, are going to have 10. And the last one, the F, is going to have 14. So now all we have left is to figure out how many electrons are in that 5D. So let's count over for platinum. And we see that platinum is starting at the beginning of 5D, 1, 2, 3, 4, 5, 6, 7. It's the 8th element over, which means it has 8 electrons in that last 5D sublevel that it has. So we're going to finish off its configuration with an 8, and that's the electron configuration for platinum.